Hello, this is Paul from Foresight Tech. In this lecture, we're going to deal with uniform distribution, which is a continuous random variable. We discussed binomial before, right? So that's a discrete random variable. It's different from the uniform distribution. So first, let's go to the definition to find the basic probability. Okay. And what the definition for a uniform distribution? Okay, the notation is this. X is the random variable. We call the X follow uniform. See, this U is a uniform distribution over the interval A to B. Okay, what does this mean? What does this random variable mean? Random variable X is a continuous first. I mean, the X could be pick all the numbers between A and B, arbitrarily or evenly. Okay. What does evenly? Later we have showed this figure so you will understand. So give an example, two examples. The first, if your child is going to ride the bus, school bus, sometimes with like 1 minute, sometimes with half hours, still possible, right? Okay, if I say 0, sometimes probably you don't need to wait. And if the minimal wait time is 0, the maximum wait time is 30 minutes. So we can usually deal with this type of distribution. This is the uniform distribution. Means what? No matter what kind of time, like if you wait like 5 minutes, every time I have the same chance. With 5 minutes, the same chance with okay, the 5 minutes from 0 to 5 or from 5 to 10 or whatever. Okay, if the time, the duration fixed, and the chance is always fixed. Okay. And another is duration of a baby's life. Okay, it's a life like 1 second to 30 seconds or 60 seconds is uniform, arbitrarily. Okay, and let's go into here is only tell you what's the variable for x and the arbitrary pick between A and B. So how to deal with the probability? We need the probability density function, PDF, still PDF. Remember, when we learn like a binomial, when we learn discrete probability distribution, that's different, right? It's not called a density. And there, D is called a distribution. Okay. In that case, PDF is a probability distribution function. Here, we change a little bit. Okay, density function, but still use PDF. Where is the density function? The probability density function is this. It's a piecewise function. It's a easy function, and that the function defined as this. When x between a b, remember a b is all the possible value for x, right? And then have the same chance. Can you see? 1 over b minus a is a constant number. If we draw a graph, is a constant number. Okay, that means the horizontal line, the line segment, of course. And other than a b, okay, we don't have any chance. Okay, which means 0. And if we look at the function, can we look at the density functions? It's just a horizontal line segment here. And if we highlighted this on the area, is exactly what a rectangle. That's going to count if the to calculate the area, if the area equals 1 or not. So what is the width? The width definitely is from A to B, right? Okay, A to B is the width of this rectangle, which is b minus a. What is the height? How high? Remember, how high is 1 minus b, 1 over b minus a, and is exactly is how high the function, or how high is the rectangle. 1 over b minus a. Can we do calculation? We use the width b minus a times the height. Okay, it definitely is the reciprocal of this number, right? These two numbers we time together, we definitely get 1. Okay, so this is very important. I mean the what? And the density functions, we can draw a rectangle with the area of 1 to describe the density function. Okay, do you remember? Have we defined the PDF for discrete variable? Yes, we do. Does that the two definitions are consistent? Yes, definitely. Can you look at this? Okay, so here I have another example. So we go over PDF for discrete. That's the probability distribution function. and then we will see the area also equals 1. They are the two cases definitely are consistent to each other. Okay, one example is this. The PDF is this. So I guess the positive value is 0, 1, 2, and the probability is 0.25, 25%, 50%, 25. If you add them together is 1. And these added together is 1 means the area is 1. Why? If we draw this graph, remember we draw this graph before, right? And when X peak 0 has 25%, peak 1 has 50%, this is high. And this is like the density, this is not the density, it's like a histogram last time we did, right? And the peak 2 is like a 25%. If you're going to find the area exactly equals 1. This equals 1, or you remember is just equal to that one. It's all the px put together equals 1. Do you remember? This is the basic definition for PDF, right? For distribution, okay? For the probability distribution. I mean that here is the same. Very, very similar. Don't forget this rectangle. Now we directly going to deal with how to find the probability. Use this rectangle. Can we see? Here is the definition first. So we have a definition. If X is follow uniform distribution, and then can we look at it? AB is the minimal or the maximal possible value for X, right? If we have another 2 point C to D form an interval, see, X is a variable between this interval. What's the probability? The probability is fraction. Can we see the pattern? The bottom is B minus A, okay, is just the range of the order possible. Remember this, B minus A is the denominator, what's the numerator? Is D minus C, which exactly is what the question they ask, right? If ask C to D, and then the top is D minus C, and the bottom is B minus A. And the definition is not complicated, but it's not easy to understand if we draw a graph. Can you see? And then finally, we will say this probability is just a kind of area, okay? It's shadowed rectangle. Why? Now we look at this. Okay, remember this box rectangle, the big rectangle from A to B, and it has the height is 1 over B minus A. That's the definition of PDF, right? Of a uniform distribution. Okay, and then we look at it. If we highlight another small rectangle, okay, the width is from C to D. And we see AB is the big one. Inside we have a C to D, a small interval. Okay, so make this and then draw a vertical line, and then highlight. And then we were going to see the area of this small rectangle exactly equals this probability. Okay, we're going to count. What's the width? D minus C. What the height? Exactly this number, right? So 1 over B minus A. If we're going to do calculation, the width times the height, do you think the width times the height means the width divided by B minus A exactly consistent with the probability? Okay, so finally we will have these results. These results are very important. Okay, so area of the shade of the rectangle, this red one, I highlighted one. The area of this one exactly is the probability for X below CD. I mean, now probability for uniform distribution can be described by an area. Okay, so we always use this idea. Probability is just an area. Okay, so the probability questions we mapping to a basic mathematical questions just to find the area. In the future, if you go to calculus, go Calc 1 and the Calc 1, the Calc 2, especially Calc 2, we all deal with how to find the area. Okay, so don't worry about the area. No matter the shape is regular or not irregular, we always have mathematical tools. If we convert it to this area, can we look at this special case? How about the X equals a single point? Do you think like your child is going to pick a bus, to ride the bus? Do you think X means the waiting time equals 1 minute? Can you find the probability, the chance? It's too hard. Okay, it's just 1 minute. Why? Because a little bit more, a little bit less, you can imagine how many times to pick infinitely, okay? You find infinite number to pick one number, the chance is just 0, okay? Or we can use the area. So can we look at it? Can we look at the x equals c means what? C is here. Can we find the rectangle? Definitely, we don't have c to c means what? The width is goes to 0. The width goes to 0. So 0 times the height is the 0. In this special case, the area means the small rectangle just reduced to just a 9 segment. Okay, means no probability, right? This is a very special case. So if we have this definition, now we can determine. I will have a lot of examples to show you how to find the probability, and you can use this definition, or you can use this diagram. And usually we will use this diagram to find the probability because this is intuitive, right? It's easy to be seen. So we easily look at this area. How to do? The first step, draw the big box, which is the distribution, right? Remember, the area of the big box always equals 1. The second is shadow the area you are going to find the probability, shadow. The third step is find the area of the shadow the one. Keep in mind 3 steps. The first, draw big box distribution. The second, highlight the probability. The third, find or do calculation of the area, which is the probability. Now I have a lot of examples to show you. Be patient. I have 6 examples. The first example. Can we look at this? These are real questions. If we say the age of customers at a local store follows a uniform distribution. See, another example. The age follow a distribution. Distribution over uniform distribution is follow A to B. Remember, see here is A from the interval over the interval from 15 to 75. I mean this is A, this is B. Keep in mind that this number you need to use. This number you need to use. Another is it says follow uniform distribution. Okay, what follow uniform distribution? The age. You need to make a you need to make a random variable for yourself, right? So let's look at what the questions. Find the probability that the next customer who walks through the door is between. Okay, so what the questions? The question is to ask another customer. However, we have assumption or the customer the age follow uniform distribution. So the first, we still need to set up. So how to set up? So let's set up what is the random variable. So you know the random variable we have to set up data, right? Okay. Why? Because that's the question. The question is ask you about this x. So I set up this x. Like I do this setup. If I set up x is the age of exactly they ask is the next customer. I say the age of that customer is okay. The age of the customer. No problem because that's what we exactly want to look at. Then we will have this. We will have x because it says all customer. Okay, so it's the same for this customer. It's a follow kind of distribution. What distribution? Uniform distribution. See, follow uniform distribution. Remember, this A, this B, right? What's A? What's B? So here we can find. So this A and this B, right? So the interval is from 15 years old to 75 years old. Okay, arbitrarily. Okay, the age is arbitrarily between or evenly between these two numbers. Now let's look at the questions. The questions is between this, right? So the questions. Can we get this question? This is the question. If I do the question put here, the question is asking you exactly the probability, right? What the probability that between this, okay? So if I put is x is the age of that customer between 30 and 45 means greater than 30 and less than 45, right? So this equals how many? What the chance or the probability that the questions. That's going to use the definition first. Okay, so can we go into this? I going to the method 1 as a definition. Remember we have a formula. If I put the formula here first, do you remember the formula? The probability X between C and D. Remember that formula is a fraction, right? The bottom is B minus A, so B minus A. The top is D minus C. Do you remember this formula? That's the probability formula, right? For uniform distribution. If you want to use the definition, this is the definition. This is the formula of the definition. I put it here. Now what do we need to do is find the question. See, what is C? C is exactly 30, right? Or we can see from here. Or I put it here again. Okay, so look at the questions. I'll copy the question is X between 30 and 45. That's the question. So you compare this. We know C is 30, right? But D is 45. DC we know what is BA. BA we already have that. Oh, I show here. This is A definitely. This is B always. So we have everything, right? So I have to log into the formula, see what I can get. What I can get is this. The bottom B 75 minus A 15, right? The top D minus C 45 minus 30. 45 minus 30. Yeah, it's easy, right? It's not difficult. Or I going to get the answer. This is you do calculation. Okay, I will going to do this is 15 on the top divided by 60 on the bottom, and do one more step. Calculation is 0.25. Means what the chance? 25%. The next customer will have the age between this. Okay, that's amazing, right? We definitely can find the chance. This is use the definition, and for all the future examples, I will not use the definition. I will going to use this. I will going to use the diagram. Remember, I will going to use method 2, which is the diagram. I use a graph. Okay, we use diagram. So can we see? So how do you 3 steps? So remember, the first draw bigger box, which is the distribution. The second is highlighted the small rectangle for your probability. The third step, calculate the area, right? Okay, so go through 3 steps. So I draw a graph here. The first I need to draw, right? I draw here. If this is X, this is fx, right? Okay, I will going to draw like this. Okay, can you see? This is A. This is what is number here? What is number here? And what is the height? The number here. If this y is 0, can you see? The first we need to determine what's the variable. Can we do? Because the uniform distribution for AB, so this is A, this is B, remember this, and the total area equals 1. Okay, so first I was going to determine what the number here is A, 15, good. What the number here? B, 75, good. See, we determine these 2. And then how to determine this? Remember, this is the PDF, right? Which if I do calculation, that's 1 over B minus A put there. What is 1 over B minus 1 over 75 minus 15, which is 1 out of 60. See, can you see? We'll put it here. So this we get 1 out of 60. So far, so you get the box, right? What do you get? You get the bigger box. Can you go on to calculate the area? You use the width times the height, definitely equals 1. Okay, so it means your first step is good. Now the second step, what do we do? We're going to highlight the small rectangle for your question, which means C to D, whereas C 30. See, I will going to highlight. If I simply say 30 is here, it's okay. And the 45, if 45, I say here, no problem. And then I highlight, draw a vertical line, and then highlight. See, the second step, this small rectangle tells me what? Tells me the probability is just the area. So now the last step, you know what to do. So find the area, okay? But how do you find the area? And the area of rectangle is the width times the height. We're going to determine what the width. The width is here, from this point to this point. And do calculation. What the width? The width is 45 minus 30. 45 minus 30, what I get? I get 15. Good. And then now we're going to calculate what? The height. The height is exactly this height, right? Okay, it's the same. I put here the height of the rectangle equals this number, right? Okay, so all the same. 1 out of 60. Now you have everything. Now we have everything, right? So now we're going to do the probability, the questions. X between 30 and 45 is exactly equals this area of the rectangle. How do you do calculation? Is the width, if I use W, times the height. Remember, this the formula. And then what the width is 15 we did, and the height is 1 out of 60. And you use your calculator, I get 0.25. Can you see this 0.25? This 0.25, definitely the same. Okay. And for all other questions, I will directly going to use this method. Okay, don't use the formula because this is easy. Okay, let's look at these questions. Now you know what we need to do. What do we need to do? Figure out the graph, right? So figure out it. And the first, this is the big rectangle. The first step, okay, to make this and this and this 3 questions. So the area of the bigger rectangle equals 1. This is the distribution for your random variable. So remember this, what is? And this is A. Or I simply say this is A, right? This is B, okay? And this is C and this is D. Remember, so does not matter for, and this sign you use less than equal to or less than, they are the same. Why? Because one single point does not affect your probability, because one single point has a probability 0. We did that before, right? Okay, so no matter about this. And then now we're going to, the first step, figure out the big box. This is A, which is 30. This is B, which is 50, right? So what is, okay, I will going to do calculation here. So this is should be B, okay, I put it here, is 1 out of B minus A. You have to remember this formula. Or you can say 1 is the area divided by the width, which is the height, okay? And then is what? Is 1 out of 50. See, B is there, A is there, minus 30. And then you do calculations 1 out of 20, right? Okay, good. And then I put it here. So from this, we can definitely find a 1 out of 20. So it means what? We figure the first step. The second step, we're going to highlight our probability. Our probability is from 40 to 44. If I simply say our 40 is here, no matter, okay, if I say 44 is here, remember, draw a vertical line, okay, whatever you draw another vertical line. See, highlight. So now we've done the second step, right? You already highlight. This is a small rectangle. The third step is going to do the probability. Use the width times the height. Okay, that's all. What the width? If I do calculation, did the width? Did the width? The width is 44 minus 40. 44 minus 40. What do we get? Is 4. Okay, and what the height? The height is same as this height. I just put here. So the height is always equals this number 1 out of 20. Now the probability is what? So the probability of our question equals, so do you remember the formula? Okay, here is not a difficult formula, just the area of the rectangle, which is the width times the height, And what the width we found 4, what the height we found, no, sorry, not equal, times 1 out of 20, right? Okay, and then you do calculation, is 0.2, right? So 0.2 means 20%, see, and it is the chance, how many? So 20%, okay, 20% of the chance to find that is a probability. And all the other questions are similar, so don't forget our steps. The first, figure out the big rectangle. The second, highlight the probability. The third, do calculation here, okay? So can we do this question? Now all the similar. I think you can figure it out by yourself, right? What is these questions? So first, here is A, 30, and here is B, 110. So here, okay, let's say here do the question. 1 out of B minus A, which is 1 out of okay, so you know this is A, this is B. 110 minus 30, which is 1 out of 80, right? Good. Now you find this point, 1 out of 80, which means the height of the rectangle, and later we're going to use. The second step, now going to, okay, it's different. There's no interval, just say x less than 46. First, let me pick, if I say 40, no, it does not 46. It's okay as randomly pick, okay, it's not a scale. If I say 46 is here, see, the question is x less than 46, which means what? To the left, keep in mind, to the left of this, where to stop, you can imagine where to stop, to the left. To the left, you're going to 30, you have to stop. Have you seen? Okay, I mean this probability we can exactly write in this way. Is just x less than 46, no less than 30, more than 30. Why? Because 30 is the minimum value for x. Therefore, x is between 30 and 46. Or if you read you look at the graph, definitely tell us, right? Okay, less than this, of course, is greater than 30. Now I highlight. Can you see? So this is the second step. The third step, we just find the area. So what the width? The width is this number minus this 46 minus 30, which is 16. What the height? I put the height is here. The height is the original number 1 out of 80, and then you know what is the probability. Okay, not easy, right? So the probability is here. So the probability x less than 46 is the width times the height equals 16. The width, the height is 1 out of 80. You do calculations, still get 20%, right? Okay, did the second, this one, and we look at these questions. Still the same. I will look at x less than. Okay, x less than, you know, this is just equal to this. X less than 40 should be greater than the minimum. This is the minimum, right? That greater than 20. They are exactly the same. Okay, and this is A, this is B. Okay, I'm going to figure this A is 20, this B is 40, and this question is 1 out of B minus A is 1 out of 40 minus 20 is 1 out of 20. Good. So I put the number 1 out of 20. See, the first step. The second step, x less than 40. Remember, if I say, okay, so this number 40 is not here, not here. See, can you look at it? It's 40 here. Less than 40 means between 40 and 20. That's all the possible value for your variable, random variable. So now it means what? If I'm going to highlight it, that's all I need to do. What is the area of this? It's 1, right? Okay, or if we want to do calculation, this is the width still. The width is 40 minus 20, of course 20. This is the height. What the height? The height is the original, this number, the value are the same. And then can we look at the calculation? The probability of x less than 40 is the probability between this is the width times the height. The width is 20. The height is 1 out of 20. Can you see? Definitely is 1. 100%. Why? Because 220 to 40 covers all the possible value, right? All the possible value is a probability 100%. Okay, we'll look at these questions. And can we see? Look at the first. This is A, this is B. Okay, so I'm going to figure out that this question is 10, right? This question is 70. And I'm going to figure out that this is 1 over B minus A, which is 1 over 70 minus 10, which is 1 out of 60. Good. We get it here, 1 out of 60. Okay, and then the second, this is a little bit different. X greater than 34. 34 is probably somewhere I say here. That's 34. X greater than is to the right? So how do you think? Where to stop? Okay, this is only the left. To the right should be less than 70. Why? Because this is the maximum value for X. Okay, if you highlight, definitely this is what you need, right? And if you from the figure, you also can see that probability exactly equals all X should be greater than 34, less than 70, right? Okay, this X greater than means 34 less than X, they are the same, and then less than 70 because this is the maximum. Okay, so now almost you need to deal with what the width and what the height, right? What the height. And the width is which number? Can we see? 70 minus 34 is 36, right? So the height is the same as 1 out of 60. Okay, now we have everything. So the probability we know, X greater than 34 is the area of this small rectangle. The width times the height. The width is 36. The height is 1 out of 60. You do calculation is 0.6. 60% of the chance the variable going to here. Okay, or you simply say 60% of the area among all. Okay, the same. The last question. We still going to do. Here is A. Here is B. No problem. The first step 20. I know everyone knows, right? 40. Then going to deal with that is 1 out of B minus A is 1 out of 40 minus 20 is 1 out of 20. Okay, we'll put here is 1 out of 20. The second step, X greater than 40. Okay, this time we have trouble, right? X greater than 40. See, you already find that X equals 40. Greater than. So we have to stop. Just stop at the same point. Why? Because 40 is already the maximum. Or you can think about this. This just means 40 less than X, right? And then X greater than 40. See, and the X should be less than 40. Do you remember? Why? Because that's 40 is the maximum. X should less than the maximum. So I put a 40 here. How do you think? Where is the rectangle? No rectangle. See, no small rectangle. No smaller rectangle means what? No area means no probability, right? Or you can say the width is 0. The width is 0. Or you can say the width equals 0. Why? Because it's 40 to 40, the width is exactly 40 minus 40 is 0. Okay, and then you know we definitely find the probability of that X greater than 40 is okay. If you say is that the width times the height, the width is 0. The height is, of course, is 1 out of 20, right? The height, no problem. The height always this. The height is always 1 out of 20. See, and then you do calculation. Definitely 0 means no chance. The probability 0 means no chance. Okay, yeah, that's all. Thank you.